The transition to electric vehicles is well underway. Governments and automakers are pushing for a greener future. Yet significant hurdles remain, hindering widespread EV adoption. One major concern is the issue of battery fires. While statistically rare, these incidents raise safety concerns and erode public confidence. Another challenge is the volatile cost of electricity. Fluctuating energy prices can make it difficult for consumers to accurately predict the cost of running an EV. This uncertainty can be a deterrent for potential buyers. Furthermore, the current charging infrastructure is inadequate. Long charging times and a scarcity of charging stations create range anxiety for EV owners. These limitations make EVs impractical for long journeys and contribute to a sense of inconvenience. Finally, the environmental impact of EV battery production is a growing concern. Mining for rare earth minerals and the disposal of used batteries pose significant environmental challenges. These issues need to be addressed to ensure that the transition to EVs is truly sustainable. Imagine a world where electric vehicles never need to stop to charge, where range anxiety is a thing of the past. This futuristic vision is closer than we think, inspired by a childhood toy, the Tyco slot car. These miniature racers draw power from the track itself, eliminating the need for bulky batteries. This same principle can be applied to real-world EVs, revolutionizing transportation as we know it. By embedding electrical conductors in the road surface, we can create a system where vehicles draw power wirelessly while in motion. This technology, known as dynamic wireless power transfer, has the potential to eliminate many of the challenges facing EV adoption today. Just like the slot car seamlessly draws power from the track, imagine EVs gliding silently down the highway, drawing energy from the road beneath them. This innovative approach eliminates the need for large, expensive batteries, reducing the weight and cost of EVs. It also addresses safety concerns associated with battery fires and environmental issues related to battery production and disposal. Electrified roads, while seemingly futuristic, are based on well-established technology. The concept involves embedding charging infrastructure directly into the road surface. This infrastructure consists of coils embedded in the road, which generate a magnetic field. When a compatible EV drives over these coils, a receiver on the vehicle's undercarriage picks up the magnetic field and converts it into electricity, charging the vehicle's battery wirelessly. This dynamic charging system allows EVs to draw power continuously while in motion, eliminating the need for lengthy charging stops. The technology can be integrated into existing road infrastructure, either during new road construction or through retrofitting existing highways. While the initial investment cost may seem daunting, the long-term benefits, including reduced battery costs, lower energy consumption, and decreased environmental impact, make it a compelling solution for the future of transportation. The adoption of electrified roads offers a compelling array of benefits, transforming the way we think about transportation. Firstly, the elimination of charging stations would free up valuable urban space. No longer would we need sprawling charging hubs, making room for parks, housing, or other essential infrastructure. Secondly, electrified roads would significantly reduce the cost of EVs. Without the need for large, expensive battery packs, the price of EVs could plummet, making them accessible to a wider range of consumers. This would accelerate the transition to electric mobility and contribute significantly to global efforts to reduce carbon emissions. Lastly, electrified roads have the potential to improve traffic flow and reduce congestion. With continuous power supply, EVs could maintain a consistent speed, reducing stop-and-go traffic and improving overall traffic efficiency. This would not only save time but also reduce fuel consumption and emissions from gasoline-powered vehicles still on the road. While the concept of electrified roads offers a tantalizing glimpse into the future of transportation, its realization is not without challenges. One of the primary hurdles is the sheer scale of infrastructure overhaul required. Retrofitting existing roadways with this technology would be a monumental undertaking, requiring significant investment, coordination, and disruption to existing transportation systems. Moreover, ensuring the durability and resilience of the electrified road infrastructure is crucial. These roads must withstand the constant pressure of heavy vehicles, varying weather conditions, and the test of time. Developing robust and weather-resistant materials for these roads is essential for their long-term viability and cost-effectiveness. Furthermore, establishing a standardized system for electrified roads is paramount. Interoperability between different car manufacturers and charging technologies is essential to ensure that all electric vehicles can seamlessly utilize this infrastructure. This requires collaboration between governments, automakers, and technology providers to develop universal standards and protocols. Safety is paramount when it comes to any new technology, and electrified roads are no exception. One of the main concerns is the potential risk of electrocution, especially during wet weather. However, engineers are developing sophisticated insulation and safety mechanisms to mitigate these risks. These include weatherproof coatings, ground fault detection systems, and automatic shut-off features that activate in case of any malfunction or hazard. These safety measures will be rigorously tested and refined to ensure the well-being of drivers, passengers, and pedestrians. Another consideration is the potential impact on wildlife, particularly animals that may cross these electrified roads. Studies are being conducted to assess the potential effects and develop mitigation strategies. These may include animal detection systems, wildlife crossings, and fencing to minimize the risk of harm to animals. While the shift towards electric vehicles is driven by the need for a cleaner environment, it is essential to consider the environmental impact of electrified roads themselves. The production and installation of the necessary infrastructure will require resources and may generate emissions. However, these impacts need to be weighed against the long-term environmental benefits of electrified roads. By facilitating the adoption of EVs, these roads can significantly reduce greenhouse gas emissions from the transportation sector, which is a major contributor to climate change. Moreover, the reduced reliance on battery production, with its associated mining and disposal issues, further minimizes the environmental footprint. Furthermore, electrified roads can be integrated with smart grid technologies, allowing for better energy management, reduced energy waste, and increased reliance on renewable energy sources. The initial investment cost of implementing electrified roads will undoubtedly be substantial. However, it is crucial to view this investment as a down payment on a more sustainable and efficient transportation future. The economic benefits of electrified roads extend far beyond the initial price tag. Firstly, the reduced cost of EVs, due to smaller battery requirements, will make them more accessible to a wider range of consumers, boosting EV adoption rates and driving down the cost of electric mobility overall. This will create new markets and economic opportunities in the automotive and technology sectors. Secondly, the reduced reliance on fossil fuels will result in significant savings on fuel costs for both individuals and nations. This will translate into a more stable and secure energy future, less dependent on volatile global oil markets. The savings on fuel costs can be redirected towards other essential public services, further stimulating economic growth. Imagine a future where the hum of engines is replaced by the gentle whir of electric motors, where the air is clean and free of exhaust fumes. This is the promise of a world with electrified roads, a world where transportation is seamless, sustainable, and accessible to all. In this future, long-distance travel will be transformed. Imagine embarking on a road trip without the worry of range anxiety, stopping only to stretch your legs or enjoy the scenery. Electrified roads will enable us to reconnect with the joy of travel, free from the limitations of traditional vehicles. This technology has the power to reshape our cities, making them quieter, cleaner, and more livable. With electrified roads, we can create a future where transportation is not a burden but a catalyst for progress, connecting people and places in a way that is both efficient and environmentally responsible.